Good morning. My name is Paul Lewin. I'm the CEO and co-founder of Havoc AI, and we've got Lucas with me today. So Havoc AI is a collaborative autonomy startup, and we're focused on the maritime space. Simply put, we're trying to make Admiral Paparo's vision of making the Pacific and unmanned hellscape a reality. So we started the company in January of 2024, so we're 14 months old. But in that 14 months, we've built and delivered 31 vessels to the DoD. So the video you just saw behind me was a video of actual sailors overseas using 15 of our vessels. And just this morning, they're doing it again overseas live, right, with very minimal training. So we started this company because we didn't think the existing players in the maritime space were capable of providing the customers what they were asking for. So you have a lot of maritime companies that are focused purely on the hardware, right? So they built very exquisite and very beautiful remote control boats. They're not autonomous, and they're not collaborative, and they're incredibly expensive, and they can't build it at scale. You have other companies that are focused on purely the software. They've only run their autonomy stack on 1 or 2 boats, and you can't really say you're collaborative and autonomous if you've only tested it on 2 boats. So we set out to make it a software-defined hardware problem. So what we did was we figured out how to build these vessels affordably and at scale. Then we figured out how to integrate mature, commercially available off-the-shelf components onto our boats. That allowed us to keep the cost low and also allowed us to make our boats incredibly reliable. Then we wrote a lot of software, right? The things you see, the 10 boats walking with real users using it, that's all software-driven, right? That's what makes it work. So right now, we've got boats in Europe, on the West Coast, East Coast, and in the Pacific with various DoD customers. And so our approach is working. We've delivered more autonomous vessels to the DoD than any existing players out there who are only 1 year old. We also don't like to just talk. We like to show. So what we're about to show you is a real-life demo. So we put 4 boats on the water back in Rhode Island. You have to excuse the weather. It's raining very heavily. But you see those are live boats that we just put on the water. And Lucas over here is going to control it using our command and control software. So we spent a lot of time focusing on what we call human-machine teaming and human factors. If you're talking about deploying thousands of these boats, you have to think through the entire chain, right? How do you transport them easily? How does a team of 2 to 3 people launch hundreds of these boats? How does one operator use our command and control interface to make thousands of boats do real-world missions like find, fix, track, and target, contested logistics, and maritime domain awareness? So those are live boats 300 miles away that we're about to control from this stage right here. They're in a blockade formation right now, and Lucas is going to command them to. He just sent them south on a direct play. So you can see the direct play is very simple, right? Go to a point together, don't hit each other, don't hit other things. But that's the core of our autonomy stack, right? If you think about that, Lucas just commanded 4 boats to go to a place from 300 miles away by clicking on things on the maps, and it just works, right? I would encourage you when you talk to other maritime players to have them do that simple task and see how many of them succeed. So the next thing he's going to do is what we call find, fix, investigate. This is, say you're trying to search an area of the ocean for a target out there. What we don't want you to be able to be an expert in autonomy, robotics, or even boats, right? The users for these boats are going to be warfighters. They don't want to understand search algorithms and things like that. So how is Lucas going to tell them to search an area? He's going to draw a box in the ocean and put some parameters and say, go search this area. And you'll see these boats in about 10 to 15 seconds responded to it. So in that 10 to 15 seconds, they communicated with each other, and they split up that area, and then they executed a very sophisticated search algorithm. Again, without me having to understand search algorithms, autonomy, or even boats. And what you see on the map is them providing information back about those areas there. So if we let this play, all 4 boats would search every inch of that area using their sensors, and if they found something, they would respond back Unfortunately, we couldn't put a target boat out there because most of the company is overseas supporting this DoD exercise. So we have a very limited team. But again, executing a sophisticated search algorithm, right? So we've taken the next step. We're not just talking about autonomy. They're not PowerPoint slides. It's not vaporware. From 300 miles away on stage, we just executed a very sophisticated autonomous algorithm. The next thing he's going to do is a payload orchestration. So this is how we can put the boats into collaborative formations to use for sensor-specific things, but also for swarming, right? If they had found a target out there, the boats would execute collaborative tactics to try to hunt as a pack. And Lucas is going to simulate that by just giving it a simulated track, and you see the boats are closing in on it, right? And right now, they probably have a radius of about 75 meters. If you actually wanted to intercept this target, they would just collapse that radius down to 0. So you just saw us do 3 sophisticated algorithms on stage very easily, and with no training required. If I could pick anyone on this audience, in about 2 minutes, you would be able to control these vessels. The next thing we're going to show you is we're going to switch over to a simulated environment. Again, these are real, but this is what we're working towards this summer. So you can see this is a real-life scenario, and you can start to see how do you employ, in this same 24 vessels to do real things, right? This is what we're going to do this summer on the Great Lakes for a DoD exercise. So if you're in the government and know what I'm talking about, please come out and see us. But you can see 9 boats there blockading a strategic choke point, right, on the screen. And then you have boats down here searching an area for a target. And then you have other boats that found a target, intercepting it and executing a find, fix, track target play. And then you have more boats closer to the shoreline there, executing a contested logistics play. So Lucas, while on stage, can control 4 teams of 24 vessels to do this. And that's what we do at Havoc AI, right? We really mean it when we say we're going to build the systems needed for humans to control thousands of these vessels. It's not going to take us 5 years, right? We're going to get thousands of our boats into the Pacific over the next 2 years. There's a lot of talk about Havoc AI. A lot of people say, well, they just build boats. They don't do autonomy. So all the autonomy stack that you just saw on there, that's Havoc AI algorithms running. But we know the DoD customers wants us to be interoperable. So what we do is right now, if you connect to Havoc, we automatically connect to Anduril Lattice, ATAC bidirectionally, and also Minotaur and other legacy systems. But we also don't force you to use our autonomy algorithms. If the customer wants it, we let other autonomy providers deploy their software payloads as software payloads and as backseat drivers. The other thing people say is they built small boats. So we're going to show you what we're working on over the next years. So the reason we started with small boats is if you know anything about self-driving cars, you need to drive millions of miles. So if you've got 1 or 2 boats and that you've only tested them for 100 or 200 hours, I can guarantee you your autonomy stack is not mature and it's not going to work in the real world. So at this point, we've got over 5,000 to 6,000 hours testing our software on the Rampages, the smaller boats. And so our software stack is probably the most mature stack out there. We're building that 38-foot boat that's going to go 1,000 nautical miles with 1,000 pounds of payload, and will go greater than 30 knots. The software that's on that big boat is the same software that's on the Rampage. It's 80% similar. So when we put that boat on the water in a few months, it's going to work, and it's going to do real-world missions right away. I'm up on time, so appreciate it. Hope you enjoyed the demo. Thank you.